Hello everyone. We'll try to go over the review problems for your first exam, and we'll not go over all the problems. So we'll try to go over the problems, so the short responses problem. Okay, the first problem is you have to find the range, interquartile range, variance, and standard deviation. So you are given some data values. So here you have 8 data values, and you have to find the range of this data set and interquartile range, variance, and standard deviation. Okay, so the range actually is the difference between the maximum value and the minimum value. So here the maximum value is 34 and the minimum value is 15. So the range will be the difference between max and min. So which is 34 minus 15 is 19. Okay. So the next one is interquartile range. So to find the interquartile range, first you have to find the first quartile, which is Q1, and you have to also find the third quartile, which is Q3. So, and the interquartile range is the difference between the first quartile and the third quartile. If you look at here, then you will see the interquartile range, IQR, is the difference between Q3 and Q1. Okay, so how can you find the value of Q1 and Q3? So if you look at this Excel sheet, then you will see here I entered all the values here and I reordered them in ascending order. That means smallest to largest value. So the smallest one is 15 and this is 34. So to find the quartile, first you need to reorder them in ascending order or descending order. That means either in increasing order or decreasing order. Okay, so to find Q1 and Q3, first you need to find the median. So the median means the middle value of this data set. So how can you find the middle value? So you have here total 8 values. So to find the middle value, so if you look at here, there are 2 values in the middle. So the middle value or the median will be the average of these 2 numbers. But if you have 7 numbers, suppose the number of observation is odd. So here you have 8 numbers. So that's mean the number of observation is even. Suppose if you have 7 values, then what will happen? Okay. Control V. Oh, I'm sorry. So first you need to copy them. So copy 7 numbers from here. Okay. Control V. And okay. So here we have 7 numbers. So in the middle we have just one value. So if you look at here, this is the middle value. So there are 3 values on the top and 3 values on the bottom. Okay, so below this number. So that's mean this is the middle number. So we have just a single number in the middle. So in that case, this is fine. This is the median value, which is 24. But here we have 8 numbers. So in the middle, we have 2 values. So that's mean the median will be the average of these 2 numbers. So the median will be the average of these 2 numbers. That's mean average of 24 and 27. So, but we have to find the quartile. So how can we find the quartile? So the quartile means, the first quartile means, so since the middle value is in between 24 and 27, so that's mean above the middle value we have 4 numbers, and below the middle values we have another 4 numbers. Okay, so let's go back to the problem 1. So here we have 4 numbers, 15, 20, 25, 25. And the middle value is in between 25 and 27. So to find the first quartile, you have to find the middle value of these first 4 numbers. And similarly, if you look at these 4 numbers, you will see in the middle, there are 2 numbers, not a single number. So similarly, to find the Q1, you have to take the average of these 2 numbers, 20 and 25, which is your Q1. So Q1 is the average of 20 and 25, which is 23.75. Similarly, below the middle value, below the median, we have 4 numbers. So to find the middle value of these four numbers, that's mean Q3, you have to take the average of these two numbers because we have two numbers in the middle, not a single number. So the middle value of these four numbers will be the average of 28 and 30, which is 28.5. So now we have Q1, Q3. So to find the interquartile range IQR, you have to take the difference of these two numbers. So the difference of these two numbers will be actually if you take the average of this number, I'm sorry, this number is calculated using the command in Excel sheet. So, but in your case, the numbers will be different. Q1 will be, if you see here, Q1 is 22.5 and Q3 is 29. So the interquartile range will be the difference between these two numbers. So that's been 29 minus 22.5. So it will be 6.5. But in Minitab, the answer is 8.25 because they calculated the quartile Q1 and Q3 using different formula. So we are not going to discuss that formula here. So if you are asked to find the interquartile range in your exam, so you will be using this method, okay? Even if you get the wrong answer, I will give you full credit for this problem, okay? So if you follow this method. Okay, so now we have to find the variance and standard deviations. To find the variance and standard deviation, one way is you can use the Excel sheet, or you can also calculate it by hand using the formula, okay? So how can you find the variance? So the easy way is you can use this command VAR. So that's mean to find the variance, you have to just do is equal sign, then you have to write VAR. So that's mean the variance, this one. And then you have to select all the numbers. So I selected all the numbers and closed the parenthesis. You will get the variance, which is 34.57143. So here we have the variance. Here we have the variance, okay? Now we have to find the standard deviation. So to find the standard deviation, one way is the standard deviation is the square root of the variance. So here the variance is this one. So if you take the square root of this number, then you will get the standard deviation. So the square root of this number is 5.879747. So which is the standard deviation? Or you can use the STDEV command to find the standard deviation. So first equal sign, then standard deviation is the EV here. This is the standard deviation. Now select all the numbers, close the parentheses. You will get the standard deviation, which is 5.879747. And you have to take round to 2 decimals. So it will be 5.88, okay? So the answer is 5.88. Similarly, for number 2, you can use the Excel sheet or you can use the formula. So now I'll show you how to use the formula to find the variance and standard deviation, okay? So let's use this pen. Okay, so the formula to find the variance is, it is denoted by S squared, which is 1 over n minus 1 and xi minus x bar square. Okay, or you can just write in the denominator it will be just n minus 1, and in the numerator it will be, actually you will have summation here, so you will have summation here, xi minus x bar square. Okay, so here x bar is the mean, here this x bar is mean, this mean the sample mean, so the average of the values, so of the numbers. So here you have 8 numbers. First you have to calculate the average of these 8 numbers, so which is x bar, and then xi minus x bar. So that's mean you have to subtract mean from each number. Then you have to take the square of this difference and then add them together, then divide by n minus 1, and will be your sample variance. Okay, so you can also use Excel sheet to do this here. So we have one example here. So we have number xi, that's mean all the observations 15, 20, 25, 25, 27, 20, 30, 34, which are xi's. So now we have to take the difference of xi and x bar. X bar means the sample mean. So the sample mean is 25.5. How can I calculate the sample mean? You have to add all this number, and there are 8 numbers, divided by 8. So you can also look at the bottom. So here you have the average, that's mean the sample mean, which is 25.5, and count is the total numbers. So there are 8 numbers, and this is the sum is 204. Okay, so the average is 25.5. So now we have to take the difference of each number from the average. So here the first number is 15. So I use this formula, 15 minus, so what you can do, you can just write equal, and you can select this number, minus the average is 25.5, which is negative 10. But now you can just expand this one up to this. Then you will get all the differences. Okay. So next one is you have to take the square of this differences, is difference. So if you take the square of this one, then it will be this. The square of this one is this. The square of this one is this. You have to take all the squares. Now we have to add them together. So you have to add them together. So if you add them, then it will be total will be 242. So 242. So our formula is summation of the square of the difference divided by n minus 1. So n minus 1, n is 8 here because total number of observation is 8, minus 1, so it will be 7. So the sum is 242 divided by 7. So here you can see the sum is 242 divided by 7, which is 34.57. And we also found the variance is 34.57 here. Okay. So now to find the standard deviation, now you have to just take the square root of this number, 34.57, which is 5.88. Okay. Okay, so let's move to the next problems. So which is from probability number 3. So here you are given some information, and this is sample points and sample point probabilities. So what is the sample point? So each outcome in the each single outcome in the event is called the sample point, or in the sample, a single outcome in the sample space is called the sample point. Okay, so here are actually total 40 projects, and to complete each project there are 2 stages. First one is stage 1, and second one is stage 2. And stage 1 is design, and stage 2 is construction. So, and this is the required times to finish the first stage, and this is the required times to complete the second stage, and this is the number of months. So these 2 means for this project to finish the first stage it required 2 months, and to finish the second stage it requires 7 months. So the sample point to complete the whole project, you need 2 months for the first one and 7 months for the second one. So the sample point will be 2, 7. So 2 represents the number of months to complete the first stage, and this is the number to complete the second stage. Okay. And similarly, sample point for this one is 28, and this is the corresponding number of projects. So that's the number of past projects having this completion times. So that's mean out of 40 projects, 6 projects required 2 months for the first stage, and 7 months for the second stage. Similarly, for second sample point, we have 6 projects and total number of projects is 40. So now based on this information, we can calculate the probability, and the probability is also given here. So for the first sample point, the probability is here, the number of project is 6 and total is 40. So 6 over 40. So that's mean 0.15. So that's mean 15% projects required 9 months to complete, the project, okay? And this is also 0.15. That's mean 15% of the projects requires 10 months to complete, okay? And similarly, you can calculate the probability for this sample point, which is 0.1, and so on, okay? So let's go to the next page. So now the first question is the design stage, that means stage 1, will run over budget if it takes 4 months. So that means if the first value is 4, then it will run over the budget, okay? So list the sample points in the event the design stage is over budget, okay? So we have to list the sample point for which the design stage is over budget. That's when the first number is 4. So you have to find the sample point for which the first numbers are 4. So here the first number is 4, the first number is 4, first number is 4. So we have 3 sample point for which the design stage, that means stage 1 will be over budget, okay? So we have 3 sample points here, 4, 7, 4, 8, 4, 9. So the second question is, what is the probability that the design stage is over budget? So now you have to find the probability corresponding to these sample points. So one way is you can count the total number of projects for these 3 sample points. So here we have 4, 4 plus 8 plus 6, so 14. So the probability will be 14 over 40. Or another way is, since the probabilities are given, you can just add these 3 probability. Then it will be 0.1 plus 0.1 plus 0.15. So 0.35. So the probability is 0.35. Similarly, the construction stage, that's mean stage 2 will run over budget if it takes 9 months. So that's mean if the second number is 9 months, then the project will be also run over the budget, okay? Will be over budget. So now we have to find how many sample points are there for which the second number is 9. So now if you look at here, second number 9, that's mean this one, 2, 9. Then the second number is 9, that's mean this one, 3, 9. Then the second number is 9, that's mean 4, 9. So we have 3 sample points, 2, 9, 3, 9, 4, 9. So what is the probability? The probability will be 2, 9 is 0.1, 3, 9 is 0.05, and 4, 9 is 0.15. So it will be then 0.3. If you add them together, then it will be 0.3. So this question is, what is the probability that both stages are over budget? So that's mean first number is 9, 4, and second number is 9. So you have to find the sample point for which the first number is 4 and second number is 9. So we have just only one sample point, 4, 9, this one. So for this sample point, the both stages will be over budget. And the probability is 0.15. So the probability is 0.15 for this one, okay? Okay, so we are done with that problem. So let's move to the next one. Number 4, the prior probabilities for events. So this problem is about prior and posterior probability. So the prior probability is for 2 events, A1 and A2. So that's mean here probability of, we are given the probability of A1, which is 0.40. So this is the prior probability of event A. That's mean probability at the beginning. We do not know any other information. And this probability is 0.60. Okay. So now we are also given that, let's make it 10. Okay, we are also given that the probability of A1 intersection A2 is 0. So what does it mean? That's mean the intersection of A1 and A2 do not have any sample point. So that's mean they are empty set. So that's mean they are mutually exclusive. So that's mean they do not have any common point. So if this is A1 and if this is A2, then they do not have any common point, right? So this is event A1 and this is A2. They do not have any common point. They are not like this. They are not like this. Okay. So here they do not have any common point. So that means they are mutually exclusive. So the answer for the first question will be, are events A1 and A2 mutually exclusive? The answer will be yes, because the probability of intersection of A1 and A2 is equal 0. Okay, the next question is compute A1 intersection B. Okay, so what is the prior probability? So the prior probability is the probability at the beginning when we do not know any other information. We do not have any other information. So now the next one is the posterior probability is actually the probability of A1, and we are also given some other information. For example, probability of B, here B is another event. So if we find the probability of A1 given B, so that's when now we are given some extra information, which is B, another event. So now we have to find the probability of A1, and we are given that B already happened or B already occurred. So that's mean some information is already known and we have to find the probability of A1. This is called the posterior probability. Here actually we update the probability of A1 based on this given information B. This is called the posterior probability. Okay. So in number B, we have to compute the probability of A1 intersection B. Okay. So how can I calculate the probability of A1 intersection B? You can use this formula. So I'll try to provide this formula for your exam. Probability of A1 intersection B is equal probability of B given A1 times the given event, probability of the given event. That's been probability of A1. Okay, so why we are using this probability of B given A? So instead of using this, you can also use this formula. Probability of A1 intersection B is equal probability of A1 given B times probability of B. You can also use this formula. But why we are not using this formula? Because this probability is not given. We do not know this information, right? We do not know this information. That's why we cannot use this formula. But we know the probability of, so we know the probability of, I'm sorry. Let me, oh, yes, yeah. So, okay, so we know this information, probability of B given A. That's why we are using this formula. So the probability of B given A is 0.20. So which is here 0.20 times the probability of A1 is 0.40, which is 0.08. Similarly, we can find the probability of A2 intersection B, and which is equal probability of B given A2, because we know this one, this probability, times probability of A2. So which is 0.03. So the answer will be 0.03. So now compute the probability of B. So to find the probability of B, so how can we find the probability of B? We only know these two probability. And we also calculated probability of A1 intersection B and A2 intersection B. So here you can see that apply Bayes theorem. So since we will apply Bayes theorem here and we are calculating the posterior probability, so we already know some information which is not explicit here, but we know it. So what are this information? Let me show you. Okay. So which information are given? Let me. Okay. So draw a rectangle. Suppose this is event B, and we can divide this event into two parts. The first one is A1 and this is A2. Okay, so we are given that A1 and A1 intersection A2 is empty. That's mean probability of A1 intersection A2 is 0. So that's mean they do not have any common points. And here you can see that A1 and A2 do not have any common points. But A1 is inside B and A2 is also inside B. So that's mean between A1 and B there is common point, and the probability of A1 intersection B is 0.08. So this part is actually A1 intersection B. A1 intersection B. So and the second part, this part is A2 intersection B. So that's mean if you add A1 intersection B and A2 intersection B, then you will get the total B. So that's why the probability of B is probability of A1 intersection B plus probability of A2 intersection B, and which is 0.08 plus 0.03. So that means 0.11. So this is the probability of B. So now we have to find the probability of A1 given B. So to find the probability of A1 given B, you can derive this formula. So from this one, you can derive this formula. So now I will show you how to derive this formula. Okay, let me show it. Okay, erase this part first. Okay. So here we have to find probability of A1 given B. So let's write the probability of A1 intersection B, which can be written as probability of A1 given B times probability of B. Okay, we have to find this probability, right? So now we can write probability of, we can divide both sides by probability of B. We can also divide this one by probability of B. Then we can cancel out this one and this one. Then it will be probability of A1 intersection B, and which is probability of probability of A1 given B, which is probability of A1 intersection B divided by probability of B. And you can see the formula for this one, probability of A1 intersection B is equal probability of A1 given B is equal probability of A1 intersection B divided by probability of B. And we already know this probability. This probability is 0.08 and probability of B is 0.11. So then it will be 0.08 divided by 0.11. So which is 0.7273. And similarly, this is called the posterior probability of A1 given B. And this formula is called the Bayes theorem. Okay, similarly, we can find the probability of A2 intersection B. So the formula for probability of A2 intersection B, we can use the same formula, which is equal probability of, probability of A2 given B is equal probability of A2 intersection B divided by probability of B. And this probability is 0.03 and probability of B is 0.11. So this one will be 0.2727. Okay. I'm sorry. I shouldn't clear the canvas because I did mistake here. Okay, let's go back to the next problem. Okay. So we need to move a little faster. Okay, so we are here. Okay, so we finished this problem. Now next, let's look at the next problem. So here we are given the following table provides a probability distribution for the random variable x. So here the random variable is x, and we are given the probability distribution. So that means the values of x. Here x has 3, 6, and 9, and the f of x is the corresponding probability. That means the probability of x equals to 3 is 0.25. So this means actually, so f of x means, okay, so f of 3, which means actually probability of x is equal 3, and this is 0.25. Similarly, f of 6 means when x is 6, f of x is 0.50. That's when probability of x equals to 6 is 0.50, and probability of x equals to 9 is 0.25. Okay, so now we have to compute the expected value of x. So what is the expected value of x? Actually, expected value of x is the mean. Expected value of x, which is called the population mean or mean or population mean. Okay, so the formula for this one is summation of x. This is called sigma x times f of x. So that means if you have to multiply the value of x with the probability of x, and then you have to add them together. So here you have first number is 3. So 3 times 0. So that's mean what basically we are doing here. So the first number is 3. Okay, the first number is 3. Okay, remove this one. So that's mean 3 times 0.25 plus 6 times 0.5 plus 9 times 0.25. And if we add them together, if we simplify them, then it will be 6. So that's mean the expected value is 6. Okay. And now then you have to compute the sigma square. So that's mean the variance. So you have to compute sigma square, which is variance, and the variance of random variable x. And the formula for this one is actually expected value of x square minus a square of the expected value, minus a square of the expected value. So now we already know the expected value of x, so we can take the square of the expected value, but we do not know the expected value of x squared. So how can we calculate the expected value of x squared? So how can I calculate the expected value of x squared? You already know how to calculate the expected value of x. So actually we have to use the similar formula. The only difference is, I will show you the difference. Okay, so we have to find the expected value of x squared, and which is actually the summation of x. So since we are finding the expected value of x squared, you have to take the square of x times the probability. There's the probability, nothing else, times the probability. So in the previous one, it was expected value of x. That's why we wrote here x. But now we have expected value of x squared. So that's why you have to write here x squared, okay? Times, and this number will be the same, f of x. So basically what you have to do here, the first number is 3. So 3 squared times the probability is 0.25 plus next number is 6. So 6 squared times 0.5 plus the last number is 9. So that's mean 9 squared times 0.25. Okay. So now you have to add them together, and that one will be 4.5. So this is, no, this is not 4.5. This is the expected value of x squared. So now you have to add them together, and this number will be the expected value of x squared minus the square of the expected value. The expected value from first problem is, the expected value is here 6. So this number minus 6 squared is 4.5, which is the variance, and the standard deviation is very simple. This is the square root of this number, square root of 4.5, which is the standard deviation, which is 2.12 here. Okay, so the next problem is, consider a binomial experiment with 2 trials. So what is the binomial experiment? So the binomial experiments mean the experiments has only 2 possible outcomes. So that's mean, for example, if you toss a coin, then you will have only 2 outcomes. Okay, so if you toss a coin, for example, if you toss a coin, then you will have either head or tail, right? Because a coin has 2 sides, head or tail. So then you will have only 2 outcomes. Okay, so here we are given the probability of p is equals to 0.08. And in our case here, we have 2 outcomes. One is S, the other one is F. So for example, if you consider, if you get head, F, and if you consider this is success, and if you get tail, if you consider this is failure, then head will be S, and this one will be, tail will be F, right? So actually here in this example, we did the experiment twice. So that's mean if you do the experiment twice, in the first experiment, you have 2 outcomes, success or fail. Suppose you got success in the first experiment, then you did the experiment again and you will have 2 outcomes, right? Success and failure. Similarly, instead of getting S, if you get F and do the experiment again, then you will have S and F again, right? So after doing the experiment twice, you will have these 4 outcomes actually. First one is success, second one is success. So that's when you will have SS, you have here SF, you have here FS, and here you have FF. So you have total 4 outcomes. So I think this answer is correct. I do not see any problem in this answer. So let's look at this option. So what is the problem with this one? So in the first experiment, you have 2 outcomes, that's fine. But after getting fail, if you did the experiment and you have 2 outcomes, that's also okay. But here you have success, that's fine. Then you did the experiment again. So you we're supposed to get S and F, but here you have just FF. So this is not correct, right? And similarly, if you move to the next one, then you will see that, okay, so the next one. So what is the problem in this one? The problem is here the first two outcomes S and F, that's fine, but this is the problem, right? And this is also the problem. After getting S, you should get again S or F, not 2S. So this is not correct. This is not correct. So the correct answer will be the first one. So this is one, number one is correct. So in part B, compute the probability of one success. So here we have two success. Here we have first one success, failure. So one success. Here we have also one success. So we have these two outcomes for which we have one success, one S, right? And here we do not have any S. Okay, so F1 means the probability for which you will have one success in two experiment. So the probability will be then 0.16 plus 0.16, which is 0.32. So how did we calculate this probability? Okay, so for this outcome, the probability will be, we know the probability for S, right? The probability of S, which is 0.8. So how can we calculate the probability of F? Since there are only two outcomes, so either you will get S or F. So F is the complement of S, and the total probability, we know total probability is 1. So the probability of F will be 1 minus 0.8, so which is 0.2. So this is the total, this is the probability of F. So for probability of this outcome, probability of SS, since they are independent, this is binomial trial. So in case of binomial trial, the outcomes are independent from trial to trial. So what does it mean? That's mean getting S or F in the second experiment doesn't depend on the result from the previous experiment. Whether you will get S or F in this experiment, it doesn't depend on the previous results. So that's why it is called independent. In this case, the probability of this one will be probability of the first one times probability of the second one. So which is actually 0.64. Yeah, you can see here 0.64. Similarly, for probability for this one will be probability of S times probability of F, which is 0.16, and this is 0.16. Okay, let's move to the second one. Compute, this is problem C. Compute F of 0. F of 0 means no success. So that's when both are failure. So the probability is 0.04. And F of 2 means the probability of two success. So that's mean SS. So this is 0.64. The probability is 0.64. Now compute the probability of at least one success. So that's mean you have to find the probability that the outcome has at least one success. So that's mean this one, and this one. And the total probability is 0.64 plus 16 plus 16. So it will be 96. Okay, another way of finding this probability is, so at least one success means this is the complement of probability of no success, right? Because then probability of no success is 0.04. So at least one success will be 1 minus 0.04. So it will be 0.96. This is another way of finding the probability of at least one success in this case. But you do not need to use this one. You can just add this probability, this one, and this one. These three probabilities, then it will be 0.96. Okay. So let's say the next one, which is compute the following. Okay, the expected value. So you already know the formula for the expected value, right? The expected value is the sigma of x times probability. So x times f of x. So you already know this. Okay, now we need to, oh, I'm really sorry. Yes, now it's good. Okay, so yes, we are here. Okay, so here we have to find the expected value of x. So if x is the random variable and x denote the number of success, so we have 0 success. That means both are failure, and we have also 1 success, and we have also 2 success. So probability for 1 success is 0.32, probability for 0 success is 0.04, and 2 success is 0.64. So we know this probability. So we know the value of x, which is 0, 1, 2, and their corresponding probabilities are here. So now we have to find the expected value of x, and we know that expected value of x is sigma of x times f of x. So that's mean the value of x times the probability. So 0 times 0.04, the value of x is 1, and the probability is 0.32. The value of x is 2, the probability is 0.64. Now we have to add them together, and this is 1.6. Now we have to find the variance of x. So the formula is expected value of x squared minus a square of the expected value of x. So you already know this part, and you have to just take the square. So now we have to calculate this one. A square of this number, expected value of x squared. So similarly, you can calculate expected value of x squared. So we have already showed this one, the expected value of x squared, which is actually summation of x squared times f of x. So that's when you have to take the square of this one times the probability, a square of this number times the probability, a square of this number times the probability, and add them together. Then you will get the expected value of x squared, and take the difference of these two numbers, and you will have 0.32. So this is the variance. So the standard deviation is very simple, which is the square root of this number, square root of 0.32. So which is 0.5657. Okay, so the next problem is this one. So consider a Poisson distribution with a mean of 2 occurrences per time period. So per one time period, the mean is 2. So this is very important. Per one time period, the mean is 2. So this is Poisson distribution. So here the mean is for one time period, the mean is 2. Okay. You have to erase this one. Okay, let's use the pen. Okay, yeah, that's better. Okay. So first you have to find the appropriate distribution function for the Poisson distribution. So here the Poisson distribution, actually the Poisson distribution is, okay, the Poisson distribution function is f of x is equal e to the power minus mu and times mu to the power x divided by x factorial. So this is called factorial. So factorial means, suppose if you have 3 factorial, this means you have to multiply, you have to start multiplying from 3 to 1. So that's mean the 3, the next number is 2 up to 1. So you have to multiply these 3 numbers. Similarly, if you have 4 factorial, so that's mean 4, 3, 2, 1. So this is 6 and this is 24. So x factorial means you will start from x and then you will multiply up to 1. Okay. So this is the distribution function. So now we have to find the distribution function for part A. So here we have to find the Poisson probability function for one time period. So for one time period, the mean is 2, right? Because with a mean of 2 occurrences. So it is given that for per time period, that's mean for one time period, the mean is 2. So that's mean here the mu is equal to, right? So that's mean that f of x will be e to the power minus 2. So that's mean the first one. Here we do not have factorial, and here we have factorial, but we do not have negative here, e to the power minus 2. Okay, so the answer will be 1. So what is the expected number of occurrence in 3 time periods? Okay, so the expected number of occurrence in 3 time periods. So for one time period, the expected value is 2. So if x is the random variable, then expected value of x is 2. So for 3 time periods, so that's mean x is the random variable for one time period. So for 3 time periods, the random variable will be 3 times x. So the mean will be 3 times of the mean for each time period. And it's very simple actually. For one time period, the mean is 2. So for 3 time period, the mean will be 3 times of the previous mean, right? So that's mean 3 times 2. So the mean will be 6. Okay. So the expected value, so the answer will be 6 here. Even if you do not know this formula, it's fine, because for one time period it is 2. So for 3 time period it is very simple, right? It will be 6. Okay, select the appropriate Poisson probability function to determine the probability of x occurrences in 3 time periods. So that's mean you have to find the x probability in function for 3 time periods. So for one time period, the mean is 2. So for 3 time periods, the mean mu will be 6, right? So the function will be very simple. You have to just replace 2 with 6. So it will be this one, right? So now in part D, compute the probability of 2 occurrences in one time period. So in one time period, so that's mean you have to use this probability function. You have to use this probability function. And if you are, if this is for this problem, you have to use the probability function, this probability function, because this is 3 time periods. So the mean will be 6. Okay. So now compute the probability of 2 occurrences. That means x is 2, exactly 2. So x is exactly 2. So now we have to actually find the probability when x is 2. So that's mean you have to find probability of x is equal to. So you have to find this probability. So one way is, so you have to just plug in this number. So this is for one time period. So you have to use this function. So 2 and x is also 2. So it will be 2 to the power 2 and e to the power minus 2 and 2 factorial. So now you can use calculator to calculate the probability. So it's better to use Excel function. So Excel sheet to find the probability using Poisson distribution. So I can show you here. Okay, problem number 7. For one time period, the mean is 2. So the mean is here 2. And we have to find the probability of x is equal to 2. So here, how can we find this? This is equal, and you have to use the Poisson function. Okay, I'm sorry. Okay, you can see here Poisson. So how you can calculate it? I have also sent you a YouTube video link, so you can also watch that video, and I think you will have clear idea about computing the probability using Poisson distribution if you watch that video. Okay, so here you have to write the command Poisson, P-O-I-S-S. So you have to select this one, Poisson, and first number is x. So that's mean value of x, which is, and then next number is mean. The mean is 2 here because this is one time period, and the last number is cumulative. So what does it mean by cumulative? Okay, so if you is 0, then it is not cumulative. If you use 1, then it is cumulative. So if you use 0, then it will give you the probability for x is equal exactly 2. But if you use 1, suppose POIS is Poisson, suppose x is 2, comma the mean is, or you can use 3. So you can use 2, comma mean is 2, and if you use 1 here, then you will have different probability. See here, this probability is higher than this one. Why this probability is different from this one? The reason is, if you use cumulative, that's mean if you use 1 for cumulative, that's mean you are taking the cumulative probability. So the minimum value for x is 0. The lowest value for x is 0. So that's mean actually you are finding the probability of x is starting from 0 up to 2. So that's mean actually you are finding the probability of equals to 0, 1, 2. That's mean actually you are adding these 3 probabilities. That's mean probability of x equals to 0 plus probability of x equals to 1. Basically what you are doing probability of you're doing actually probability of x is equal 1 plus the probability of x is equal 0 plus probability of x is equal 2. Actually you are adding these 3 probabilities, but here you are just finding the probability of x equals to 2. This is not cumulative, so that's why this probability is smaller than this one. Okay, so the next one is compute the probability of 6 occurrences in 3 time periods. So you have to compute the 6 occurrences in 3 time periods. Okay, so 3 time periods means the mean is 6, so you have to use this distribution function, this probability function. So that's mean in this case the mean is 6, and we have to find the probability of x is equal 6, because 6 occurrences, that's mean the value of x is 6. So you have to find this probability where mean is 6. So you have to similarly you have to use the Poisson function, and x is 6, mean is 6, and this is not the cumulative probability, right? We are not finding the probabilities of 0 x equals to 0 to 6. We are just finding the probability x equals to 6. That's mean exactly x equals to 6, not up to 6. Okay, so that's why you have to use this 0. But if you find the probability of x equals to up to 6, that's mean from 0 to 6, then you have to use 1 instead of 0 here. Here instead of 0 you have to use 1. It will give you the cumulative probability. Okay, so next question is compute the probability of 5 occurrences in 2 times. So 5 occurrences in 2 times. Okay, so 2 times. Now we have different distribution function, right? Because 2 times mean the mean is, for 1 time period the mean is 2. So for 2 time periods the mean will be 2 times 2, 4, right? So the mean is 4 here. We have to find the probability of 5 occurrences. That's mean x is equal 5. So you have to find the probability of x equals to 5, which is 0. You have to use Poisson 5 for 0. Now, if the question is, if you are asked to find the probability of at most 5 occurrences or at most 3 occurrences, then how can we find the probability? At most 3, that means the maximum occurrences could be 3. That means actually we are looking for the probability of x less than equal 3. The maximum occurrence could be 3. That means actually the values of x, possible values of x will be 0, 1, 2, 3. So in this case, this is actually cumulative probability, right? So in this case, you have to write POI Poisson, and the first one is x. X is here 3, maximum 3 occurrences. Mean is 4, and this is cumulative, so it will be 1. This probability is 0.43347. You can also you can also see the YouTube videos. I have already sent you the link in my previous email, and I will also try to send you the link again. Okay, so the next question is, let's move to the next one. Okay, The random variable x is known to be uniformly distributed. So the previous examples are about discrete probability distribution. So that's when the values of x are discrete values. Suppose x is equals to 0, 1, 2, 3, 4. It's not continuous. It's discrete. X can take some discrete numbers. But in this case, here x is continuous. That means x can take any values between two numbers. So for example, if x is continuous and if x belongs to 0 to 2, that means x can take any values between 0 and 2. So that means x could be 0.1, x could be 0.2, x could be 1, x could be less than 2. So x could be 1.2, x could be a 1.9. So x can take infinite number of values. So this is called a continuous random variable, and the probability distribution for this type of random variable is called continuous random variable. And in the previous case, x was just some discrete number, suppose 0, 1, 2, 3, 4, 5, like this, right? Okay, so here we are given x is the uniform distribution from 1 to 1.5. So what does the uniform distribution mean? Okay, so the uniform distribution mean for each value of x, the probability is constant. That means the probability is same. So for each value of x, the probability is same. So if you look at this density function, okay, so for example, if you have a probability distribution like this, okay, so suppose if you have this probability distribution, suppose f of 1 over 4 and x belongs to 0 to 4. Here you can say x is always 1 over 4 because this doesn't depend on x, right? This is constant function. So for uniform distribution, the density function is always constant. So that's mean for any value of x, f of x is same. F of x will be 1 over 5. If you consider x equals to 0.1, it is 1 over 4. It's not changing, right? Depending on the x, this value is not changing because this one doesn't depend on x. Okay, so now the density function is not given. So how can you calculate the density function? So this, if you consider this number as a and this number as b, so if this is a, this is b. So for example, if x belongs to a and b, the minimum one is a, maximum one is b, then the density function f of a will be 1 over b minus a. So here the maximum one is 1.5 and the minimum, the lower bound is 1. So it will be 1.5 minus 1. So 1 over 0.5, which is 2. So the density function is 2. And it is 2 for the values of x when x is between 1 and 1.5. But for the other values of x, so that's mean if you increase the value, if you take the value above 1.5 and below 1, the f is 0. Actually, we have also f here, but the density of for this period is 0. That means for the other values of x, f of x will be 0. Okay. So now we have to find the graph of this function. Graph a function is f of x equals to 2 from 1 to 1.5. So you have to see here, this is 0.521. So this is not correct. This is 2, that's fine. But from 0.5, but we have 1 to 1.5. So this is not correct. So this is also 2, but this is from 0 to 0.5. So this is not also correct. How about this one? This is from 1 to 1.5 and the density is 2. Yeah, this is correct. So this is the correct answer. Okay. So the next question is compute probability of x equals to 1.25. Okay. So for continuous random, for discrete random variable, you can have positive probability for a distinct number. for a specific number. Suppose for x equals to 0, you can have some probability here. Suppose this is 0.1. But for continuous case, for a single number, for example, x equals to 0, it will be always 0. Or if you find the probability of x equals to 1, this one will be also 0. That's mean for exact value of x, the probability is always 0. Why the probability is always 0? Actually, for continuous case, the probability is actually represents the area under this curve. Okay, so the probability represents the area below this curve. So for example, if you want to find here, if you want to find the probability x equals to 1.25, 1.25 is somewhere here in the middle, so this is 1.25. So if x is exactly equal to this number, so that's mean the area of this line, right? Because yeah, the area of this line, and we know that the area for a line is always 0, right? It doesn't have any area because it has height, but it doesn't have any width. So it has just one dimension. So it cannot be a positive area, it's always 0. So for exact value of x, for continuous case, the probability is always 0. But you can find the probability in between two numbers. So compare the probability of x is greater than equal 1 and less than equal 1.25. So actually you have to find the probability of for this part. That's when you have to find the area of this part. Okay, one way is this is rectangle. So we know the height. The height is 2. So this is 2. So you already know this height. So now you have to find this one, right? This part. So this is 1, this is 1.25. So this one will be actually 0.25. So the area will be, the area of the rectangle is length times width. So that's been 2 times 0.25. This is one way. So it will be actually 0.5. You can just simply calculate the area. Or you can also use the integration. Okay, so for discrete case, you use summation. And for continuous case, the summation is actually the integration. If you have already taken the calculus course, so you already know how to find the area for continuous function, okay? So you can just integrate this function from 1 to 1.25, and I'm not showing you the details. So here you can see f of x is 2, which is the density function, you already know. So now you have to just integrate this one, and after integration you have 0.5. This is one way, and this is the another way. Just calculate the area of this rectangle, that's it. Okay, this is easier. Even if you do not know the integration, you can find it. So now you have to find the area between 1.2 and 1.5. So that's mean you have to find the area between 1.2 and 1.5. Similarly, this is, I'm sorry, this is, if you look at here, 1 to 1.5. So you have to find the area between, okay, let me erase this one first. Okay. Yeah, that will be better. Okay. Yeah. So 1.2, okay, this is 1.2. Yeah, my drawing is weird, 1.5. So this is 1.2 and this is 1.5. So that's mean basically you have to find this area. So we know the height, which is 2. So we have to just find this length, 1.5 minus 1.2. So this is actually 0.3. So if you take the difference of these two numbers. So that means the probability will be 2 times 0.3, which is 0.6. Or if you do not want to use this idea, then you can just simply take the integration of f of x from 1.2 to 1.5, and which will be 0.6. Okay, next one is, given that z is a standard normal distribution random variable, so compare the following distribution. So what is the standard normal distribution? So for you already, I think you already know the normal distribution. So what is normal distribution? So normal distribution is if a probability distribution is symmetric, bell-shaped. That's mean, okay, I'll show you. Okay, so the normal distribution is basically this is the distribution will be bell-shaped. This is not exactly bell-shaped. So the shape of the distribution will be like this. And this is the center, which is the mean. And this mean is, yeah, so this is not actually the normal distribution. It should be bell-shaped. Yeah, it should be like this. And so if you look at here, so this is the mean. So what is the standard normal distribution? So for normal distribution, if X is normal distribution, which is denoted by normal and mu sigma, where mu is the mean and sigma is standard deviation. This is mean and this is the standard deviation. For normal distribution, the mean could be any number and sigma could be also any number. But for standard normal distribution, which is denoted by Z, is standard normal distribution. That's mean the mean should be always 0 and standard deviation is 1. If the normal distribution has 0 mean and 1 standard deviation, this is a special distribution, a special normal distribution, which is called the standard normal distribution. So here this random variable is a standard normal distribution. Now we have to find the probability. So why standard normal distribution is important? Okay, so you can find the probability using Z table. And for Z table, actually, you have the probability only for the standard normal distribution. So that's why you need to always convert this distribution to a standard normal distribution to find the probability. Even if you want to use the Excel sheet, you have to use the standard. You can use both actually. Yeah. Then you do not need to convert it. So how can you convert it to a standard normal distribution? So if X is normal distribution, first you have to make the center 0. So that's mean X minus the mean of X. And you have to do also a scaling. You have to divide by the standard deviation. Then it will give you the mean for Z will be 0 and the standard deviation will be 1. Okay, so this is the formula to convert a normal distribution to a standard normal distribution. Okay, so here this is a standard normal distribution, so you do not need to convert it. First, you need to find the probability between 1.98 and 0.49. Okay, one way is you can look at the Z table, but I will show you how to find this probability using the Excel sheet. Okay, so here this is the probability we are looking for. And to find this probability, you have to use norm.dist, this function, normal distribution function. And the first one is the value of the upper limit. Okay, so let me explain this one first. If you just write norm dist a number X, so for example 0.49 comma mean, since we are the distribution is a standard normal distribution, so mean is 0 and standard deviation is 1, and we are finding cumulative. So this one will be 0.687793. So what does this mean actually? This means actually you are, okay, I'm just writing here. Let me pull up the Excel sheet. Okay, so I'm just writing here. Okay, so what does it mean actually? This means actually 0.49, this is 0, so it should be somewhere here. The value of Z is 9. So actually you are finding the probability on the left side of this number. That's when you are finding this area. Okay, so if you just look at this number in the Excel sheet, if you find the probability for this number, the cumulative probability, then it will give you the area on the left side of this number. But we are looking for the area between this number and this number. So now what will happen if you find the probability for this number using the Excel sheet? That will give you the area of this part. So if you use this number, then you will get the area of this red part, right? If you use this number, then you will get the area of this black part and the red part. But we are looking for the area only of this black part. So to find this area, you have to subtract this area from this area, right? So that's mean you have to take the difference between the probability for this number and this number. That's what we did in the Excel sheet, okay? I'll show you here. So this is actually the difference between the area for this number and the area for the smallest number. So how did we calculate this one? So you can calculate also separately. So this is the area for the largest number, and now you can norm this. Now you can find the area for the smallest number. The number is negative 1.98, comma the mean 0, standard deviation 1, comma cumulative. So this is the area. Okay, so now you can take the difference of these two probabilities. So that's mean this minus this. So you can take the difference, which is 0.6640. So exactly the same. Or you can just find the probability was just by taking the difference of norm 0.49011 minus norm. So how can we find this one? I'll show you. Equal, then we need to type norm this the largest value, which is 0.49, comma mean is 0, comma standard deviation is 1, cumulative, then end of the parenthesis minus norm dist. The lowest number is 1.98, comma mean is 0, standard deviation is 1, comma cumulative, and end of this. So yeah, one way is you can calculate the probabilities separately for these two numbers, then take the difference, or you can directly take the difference of these two probabilities. Okay, so similarly, to find this probability, you have to just take the difference of the probability for this number 1.22 and 0.52. Okay, and probability for this one will be this. Okay, so now if you just want to find the probability of, suppose if you want to find the probability of z less than 1.2, so how can you find this probability? That's mean you just want to find the probability for the values of z for which the values are less than 1.2. So that's mean you want to find the area on the left side. So this is simply norm dist. This is 1.2, comma 0, comma 1, comma 1. So this is the area. But if you want to find the probability of area on the right side, that means z greater than suppose 1.2. If you want to find this probability, then it will be actually okay. So I'll show you here. So first, let me explain this. This is 0. Suppose this is 1.2. So if you take the area less than this number, probability less than this number, then it will be area of this part. So you can directly calculate this area from the Excel sheet. So now if you want to find the probability of area on the right side, suppose this is 1.2. So that's when you want to find this probability. But if you use the Excel sheet, that will give you the area on the left side. But you are not looking for this area. You are looking for probability of z greater than 1.2. So that's when you are looking for the area on the right side, this area. So to find this area, so this is the complement of this one, right? So the total area is 1. So if you do 1 minus this part, then you will get the area of this right side. So in Excel sheet, if you have greater than sign, then what you have to do, this is equal norm this. Okay, so you have to do 1 minus. So 1 minus norm of this. So the number is 1.2, comma, mean is 0, standard deviation is 1, and cumulative. Okay. Yeah. So this is the probability. Or you can say, if you do 1 minus this, then you will have this number. Okay. Okay. So now the question is, here the random variable was a standard normal distribution. So what will happen if you do not have a standard normal distribution? Suppose if X is normal distribution with different mean. Suppose if X follows normal distribution with different mean. Suppose mean is 12, comma, standard deviation is 2. Which is the mean and standard deviation are different from the mean of standard normal distribution, right? For standard normal distribution, mean is 0 and standard deviation is 1. So in this case, if you want to find the probability, suppose probability of X less than 15, you want to find this probability. How can you find this probability? But this one, you will use the same formula, norm distribution. X is 15, comma, the mean. Now the mean is not 0. Remember, the mean is not 0 because this is not a standard normal distribution. Mean is 12, so it is 12. Comma, standard deviation is not 1, it is 2 now. 2. And we are doing cumulative, so 1. This is the probability. Okay. One way is you can convert it to a standard normal distribution by using this formula, x minus mu over sigma, or you can just using the Excel sheet, you can directly calculate the probability. But if you want to use the Z table, then first you have to convert it to Z score. Okay. So let's move to the next one. Okay, so in the next problem, this is the opposite of the previous example. So in the previous example, you were given the Z score or Z values, you calculated the probability. Now you have the probability. The probability is given. You have to find the value of Z. This is called the inverse normal distribution, not inverse normal distribution. This is the inverse or opposite of the previous one. So in this case, you can also use the Excel sheet. Okay, so here the area is the area to the left of Z. You have to be very careful. You have to be very careful about this word, whether the area is on the left or in between or on the right, because depending on this, you will have different results. Okay, so here the area is on the left, so this is pretty straightforward. So the area is 0.2119. You have to find the Z score. In the previous example, the Z score was given, you calculated this area. Now the area is given, you have to find the Z score. So how can we find this one? So we'll go over an example here. So here we have the Z score is, so area is 0.2119. So the area is 0.2119. Okay, that's fine. So we have to find the Z score. Find this, you have to do norm dot inv. That's mean inverse. So you have to use this comment. So now the probability means the area on the left side. Be careful. This is the area on the left side, not any area. Since this area is area on the left side, so we can just directly write this number 2109, comma, the mean is, since this is standard normal distribution, 0, standard deviation is 1. That's it. You do not need any other information. Okay. So this will give the Z score is negative 0.79985. So if you round to 2 decimal places, then it will be negative 0.80. And you can see here, the result is negative 0.80. Now you have the area in between these two numbers, in between negative z and z. So that means this z is same number, one is negative, the other one is positive, but you have to find this z. You are given this area in between these two numbers. The area is negative 0.9030. So now how can we find this value? So if you know this area, that's mean area on the left side, or if you know this area on the left side of this number, then you can easily find the value of z. Okay, but we do not know this area. We know the area in between these two numbers. So to find this area, we know that the total area is 1. And since this number and this number are same, and this is bell-shaped, this is symmetric, so when you have a negative value and positive value, so that means you have same value with negative sign and positive sign, the area on the left side and the area on the right side will be same. So that's mean the area on the left side of this negative number, since this number is same with opposite sign, in this case, the area on the left side of this negative number is same as the area on the right side of this positive number. So that's mean this number area and this area are same. Okay. So the area in the middle is 0.9030. So the area of the shaded region. So the total area is 1. To find the area of the unshaded region, you can subtract this number 0.9030 from 1. So that's mean 1 minus 0.9030 will give you the area of this one and this one. Since these two areas are equal, then you can divide this number by 2 to get this area, right? So what you can do here, actually, you can do, you can do 1 minus 0.9030. That will give you the area of this one and this one. Since they are same area, so you can just divide this number by 2. So divide this one by 2 to get the area of this part, area of this one. Why do we need this area? Because we want to find this number. And to find z square, we need to know the area on the left side if you want to use the Excel sheet. So now go to the Excel. And you have to find the z square. So to find the z square, so you know the area is 1 minus 0.9030. So this will give you the area of the unshaded region. If you divide this by 2, then you will get the area of the on the left side of the negative number, which is 0.0485. So that's mean this is the area of this part on the left side of this negative number. So now you have to find the value of negative z. So how can we find this one? Equal norm dot inverse. So this one, the probability is 0.0485, comma mean is 0, standard normal distribution, and 1. So this is negative 1.65. So if you round to 2 decimal places, then it will be negative 1.66. Okay, so negative z is negative 1.66. So z will be then 1.66. So you can see here, this is 1.66. I have also sent you a video link for this type of problems. You can also watch that YouTube video. I'll also send you the link again, okay? The area between negative z and z is this. You have to find the value of z, okay? So we already did this one. And this is the, we do not have the figure for this one. This is similar to the previous one. So now if you want to find the area on the left side, the area on the left side is this one. You have to find the z square. This is pretty straightforward. So area on the left side, so to find the z square, you have to just directly use the comment norm int. And the area on the right side, the area on the right side is this one. You have to find the z-score. In this case, okay, in this case, you have to know the area on the left side. So how can I get the area on the left side? So the total area is 1. Since the area on the right side is 0.6915, the area on the left will be 1 minus this number, right? Then you will have the area on the left side. And if you have the area on the left side, so the area on the left side, this will be 1 minus 0.6915. This is 1. Yeah, this is 1. I'm sorry. This is 1. Yeah. This is 1. Yeah, 1 minus this one. This will be this area. So now you know the area on the left side. You can easily find the value of z, which is negative 0.5. Okay. So next one is, okay, so here you have given a data table. So the first one is the company name, and this is the available data about this company. This is the data file. This is the information about this company. So here actually this is the company name. So first one is how many variables are in the data set. So actually this is the information about these companies. So that's mean these are the variables. So we have, because the values for exchange will change depending on different companies, right? So this is MX, this is OTC, so it's changing. So this is called variable. So how many variables do we have here? 1, 2, 3, 4, 5. So we have total 5 variables. So of the following subset of variables indicate which are qualitative and which are quantitative. So qualitative means which just takes the name, not the number. So here exchange is not number. So this is qualitative. So this is also number. This is also this is not number. This is qualitative. So we have 2 qualitative variable and 3 quantitative variable. So the first one is exchange. So this is qualitative, and the second one is earnings ratio, price earnings ratio. So it is quantitative because they are numbered, right? Yeah. And sometimes you will see some numbers for variables, but they are not quantitative. Okay, so I'm not going to discuss that one. For example, okay. So now the gross profit margin is quantitative because they are also numbered. So this is quantitative. So for the exchange variable, show the frequency and percent frequency for MX, NYSE, and OTC. Okay. So here, this is the 3 different type of exchange. So, and frequency, that's mean how many times each one occurs. So how many times MX occurs, how many times this one occurs, how many times this one occurs. So we have, how many times we have MX? 1, 2, 3, 4, 5 times. So the frequency is 5. And for this one, the frequency is 3 because this one occurs 3 times. And OTC occurs 17 times. So that's mean the frequency is 17. So the total number is 25. So percent frequency actually which also represents the probability actually. So the percent will be 5 over total, 5 over 25, so 20%, 3 over 25, 12%, and 17 over 25 is 68%. Total is 100%. Okay. So now you have to find the frequency distribution. So frequency distribution means the values of the variable and their corresponding frequency. So here we have 3 values for exchange, MX, OTC, and NYSE. So we have these 3 values for exchange, right? So so now you have to find the values for the variable will be on the x-axis and frequency will be on the y-axis, on the vertical axis. Okay. So here you can see for MX the frequency is 5. Is it correct? part A. Oh, okay. So this is actually percent of frequency. So for the first one, the percent is 20%. So 20, yeah, that's fine. For this one, the percent is 12. I think this is also okay. For this one, the percent is 68. I think this is also okay. So the first one is correct. What's problem with the second one? It should be 20%, but yeah, this is 20%, that's fine. But this should be 12%, but this is 68%. So this is not correct. And similarly, C is not correct. Okay, if you look at C here, C and D, you will see that, yeah, this is not correct. This one is not correct. And for this one, this is not correct. It should be 20%. Okay, so the answer would be A. Okay, show the frequency distribution for the gross profit margin using the 5 intervals below. Okay, so we have these 5 intervals. Now we have to find how many times, so how many numbers are between 0 to 14.9 for gross profit margin. So we have the values. So you have to look at here and you have to see how many numbers are between 0 to 14.9. 14.9, yes, 14.9. So there are 2 numbers which are between 0 to 14.9, and we have 6 numbers which are between 15 to 29.9. We have 8 numbers which are between 30 to 44.9, and we have 6 numbers which are between these 2 numbers, and we have 3 numbers which are between these 2 numbers. Now, based on this information, you have to find the frequency distribution. So the x-axis will represent this gross profit margin class. So this are called the class of gross profit margin. So we have 2, 4, 5 classes. So first one is 0 to 14.9. So that's fine. And what is the frequency? Frequency is 2. So this is correct. For the next one, the frequency is 6. This is also correct. For the next one, the frequency is 8. This is also correct. For this one, the frequency is 6. This is correct. The frequency is 3. This is also correct. So the first one is correct. So what's problem with the second one? If you look at here, this is not correct. Here the frequency is 3, but it should be 6. And for this one, the frequency for this one should be 3, but this is 6. So this is not correct. And similarly for part D, yeah, if you look at this, this is not correct. Okay. So if you look at this one, yeah, 2, then 6, then 8, then 6, but this is not correct. Yeah, this should be 3, but this is 8. Actually, I did mistake here. With the correct histogram for the above diagrams, actually it should be 8. Yeah, I did. Yeah, I selected this one, but when I wrote the answer, I did mistake. It should be A. Okay, so what is the average price earning ratio? So to find the average, you have to just take the average of all numbers. Then the average is 20.2. Okay. So consider the following frequency distribution. So now we are given some classes and corresponding frequencies, and this is the frequency distribution. So which of the following histogram accurately represents the data? So now you have to find which one is correct frequency distribution. So for the first class, the frequency is 10. So this is not correct. This is 14. So this is not correct. How about this one? This is 11. So this is not also correct. Yeah. How about this one? Yeah, this is 10. Yeah, I think this is correct. You can also check the other frequencies. Okay. So number 3 is correct. Okay. So the next problem is we have here the information about the male golfers and the female golfers. Okay. So here the handicap under 15, and this is 15 or more, and too fast, and this is just fine. Okay, so that's mean there are 10 golfers which are under 15 and too fast, and there are 14 golfers which are under 15 and they are just fine. And there are 15 or more golfers which are too fast is 25, and 25 are 15 or more, and they're just fine. So they're 25. So this is the information. So now we have to complete this table. Okay. So here we have just gender, male and female, and here this is the green condition, too fast and just fine. Okay. So male and too fast. So you have to look at here. You do not need to consider this one because we have these are male and too fast. So how many are there regardless of the is? So this is, we have 10 plus 25, 35. So it is 35. And male and just fine is in green condition is just fine. So this is 40 plus 25, it will be 65. And similarly for the female and too fast are 39 plus 1, which is 40. And female and just fine is 51 plus 9, which is 60. So the total male will be 100 and female is 100, and total too fast is 75, and total fine is 125. So now the question is, which group shows the highest percent saying that the greens are too fast? So which group? That means female or male? That which group are saying that the greens are too fast? So you have to just consider green and too fast. So this is green for male, and this is green for female. So this is also the information about the green condition. So male and too fast is 35 out of 100, right? Because total male is 100 and total female is also 100, and too fast is 40. So now you have to calculate the percentage for this one. So 35 over 100 is 0.35, 40 over 100 is 0.4. So which percentage is higher? The female is higher, right? So that's mean which group? The female group, and the percentage is 40%. Okay. So refer to the initial close tabulations. So that's mean these tabulations. For those players with low handicaps, that's mean better players, which group shows the highest percentage saying the greens are too fast? So that's mean which group shows the highest percentage? For those players with low handicaps. Low handicaps means under 15. So we have to consider under 15 and the green condition. So under 15 too fast for male group is 10, and for female group is 1. So which group has higher percentage? So which group has higher percentage? Sorry, for the male you have, for the lower handicap this is 10 and this is 1. So that's mean if you calculate the percentage, then you will see that men have higher percentage than the women who think that the greens are too fast. Okay. So refer to the initial cross tabulations for those players with higher handicaps. That's mean 15 or more, and for the female 15 or more. So higher handicaps, higher person who think that the greens are too fast. So now you have to also consider, so this is 25 out of 50, right? So there are total 25 plus 25. So out of 50, 25 things that too fast. And among this group, female and 15 or more, there is 39, and total is 39 plus 51. So the percentage for male, this is 25, 25, they are same. So 50%. 50% things that too fast, and 50% things that's just fine. So with the higher handicap, that's been with 15 or more handicap, and in green condition, 50% of the male think that is too fast, right? And here is less than 50%. So that's mean male has higher percentage. So it will be also male. How does the percentage if women think the greens are too fast compared to the percentage of men who feel the same? So you can just try to this one. If you do not get the answer, then let me know. I'm also going to send you the key. Okay. So okay, let's move to the. So we have a few more problems. I'm not going to discuss the multiple choice questions. So you will go over them, and if you have any question, you can just email me. I'll try to answer your questions, but I'm going to send you the key, okay, for those problems, for multiple choice questions problems, okay? So I think you will have total 20 questions as far as I remember. So 15 will be short responses and 15 will be multiple choice questions and 5 will be short responses. So for short responses, actually you do not have to show your work, but if you want, you can send me your work, and even if you get the wrong answer and your work is consistent, I might give you some partial credit, okay? So now we have few more problems. Here, number 39. We already this is about sampling distribution. So I have also sent you a video about sampling distribution. So what is sampling distribution? The sampling distribution means, for example, if you have a population, suppose this is the population, suppose you want to know the average score of the students for this course. So you're taking 2345 course, and there are several sections. So suppose you want to know the average score of the students of this course. So there are too many students. So sometimes it is not easy to calculate the average for all the students. Or for example, if you want to know the average height of the US population. So it is not possible to measure the height for each person and then take the average. So what you can do, you can just take a representative sample. Maybe you can consider 100 people randomly. You can select 100 people randomly, and you can measure their height, and you can take the average height, and based on this, you can make inference about the height of the total US population, okay? So here, the height of the US population is the population, and the sample is the selected 100 peoples are the sample, okay? So now, suppose if you have a population, and now population of 100 observations, and you want to take a sample of 10 observations. Suppose you have the score of 100 students, and you want to consider the score of 10 students. So what you can do, you can randomly select 10 scores from these 100 scores, right? So how many ways you can do this selection? You can do this selection in many ways, right? So first you can take 10 scores from any 10 scores from here, then you can take any other 10 scores from here, and you can take again 10 scores from here. So you can draw many samples from here, right? Again, take 10 scores from here. Okay, and you can take the average for this 10 score. Suppose this is the first sample, so this is suppose x1 bar, average of this 10 scores, and this is suppose x2 bar, and this is x3 bar, this is x4 bar. Now you will take all the possible samples of 10 of size 10, and you can get the average for each sample. Suppose if the total number of sample is 10,000, then you will have 10,000 average, right? So these average values, will also follow a distribution. So if the sample size is large, usually consider if it is greater than 30, but there is no exact rule about this, but usually consider greater than 30. So if the sample size is 30 or more, even sometimes it depends, actually it depends on the data. Sometimes even if you consider sample size less than 30, it might also follow normal distribution. Okay, so now this average, suppose you have 1,000 average, 1,000 sample average. This average also follows some distribution, which is called the sampling distribution. Sampling distribution of mean. Okay, so now if the sampling distribution, if the population is, if our original population is normal distribution, if we know this distribution, then for sure the sampling distribution will be also normal distribution. But if we do not know this distribution, if we do not know the population, distribution of the population, then we do not know what will be the distribution for the sampling distribution. But if the sample size is large enough, then regardless of the distribution of the population, the sampling distribution will be normal distribution. Okay, so here we have the sampling distribution, and we have the distribution of the population is we do not know the distribution, but we know the mean, which is 183, and the standard deviation is 50. And here the sample size is 30, so we can consider the sampling distribution is normal distribution because the sample size is large enough. Okay, so now the sampling distribution, that means in this case the random variable is the mean, the average, the sample average, which is also normal distribution with mean mu and the standard deviation sigma x bar. So our original distribution was x. We didn't know the distribution, we just know that mean is mu, which is 183, and standard deviation is sigma is equals to 50. We just know this now. And the sample size is 30, but we do not know the distribution of x bar, the sampling distribution. So since the sample size is 30, which is large, we can consider this sample size is large. So we can say that this is called central limit theorem. Using the central limit theorem, we can say, or this is called CLT, x bar is the sampling distribution of mean, which also follow normal distribution with mean mu, and variance is sigma x bar. So mean will be same, but the standard deviation is different. For the population distribution, the standard deviation was sigma. Now it is sigma x bar. So what is the difference between sigma and sigma x bar? Sigma x bar is actually sigma over a square root of n. So sigma x bar is sigma over a square root of n. So if you increase the sample size, that will decrease the value of the standard deviation. Okay. So here, what is the probability that mean price for a sample of 30, that's when sample size is 30, and within 8 of the population mean. So what is the population mean? 183. Within 8. That's mean the number above 183 will be 183 plus 8, and below this number will be 183 minus 8. So within 183. That's mean you have to add 8 with 183 and subtract 8 from 183. Then the number is 175 and 191. You have to find the probability between these two numbers. And here is saying that the mean price for the sample. So that means you have to find the probability of x bar. That means you have to use the sampling distribution. So basically you have to find the probability of x bar is between mu minus 8, x bar less than equal mu plus 8. You have to actually find this probability. Mu is 183. Okay, so what do we know about the distribution of X bar? We know that X bar is normal distribution with mean mu. So here mean is 183. So what will be the sigma? So sigma X bar is sigma over square root of n. Here sigma is 50 and n is 30. So sigma X will be 50 over a square root of 30. So now you know and this is normal distribution. So you know the mean, you know the standard deviation. So you can use the Excel to find the probability between this number and this number. So I'll just show you one example. I'll just show you this example. So this is normal distribution. So first calculate the sigma X bar. So sigma X bar, calculate this one, which is equal 50 over 50 divided by SQRT, the square root of the sample size, which is 30. This is 9.187. So this is the standard deviation. Okay, so the mean is 183. So now we have to find the probability between 175 and 191. So norm, the probability between X is, the highest number is 191. So first you have to consider the highest number, comma, the mean is 183, comma, the standard deviation is, we already calculated this on 9.128. So we can just consider 9.129 and cumulative. And minus norm of this one, and the lowest number is 175. So this is just 175, comma, the mean 183, comma, the standard deviation, which is 9.129, 9.129, and cumulative. So we will close the parenthesis. So this probability is 0.619148. So the probability is 0.619148. So this is the probability. Okay, similarly for this, what is the probability that the mean price for a sample of 50? Here the sample size is different, which is 50, and within 8. So that's mean this number will be same. The only difference is the standard deviation, which is 50 over a square root of 50. Similarly for this one, the mu is 183, and the standard deviation will be sigma over a square root of n. That's mean 50 over a square root of the sample size is 100, so which is 5. So now you have to just use this formula to find the probability. Okay. So which, if any, of the sample size in per A, B, and C would you recommend to have at least a 95% probability? That's means 0.95 probability that the sample mean is within $8 of the population mean. So this probability is 0.8904. This probability is less than this one. This probability also is less than this one. So there is no probability which is either 95.95 or more. So all probabilities are below 0.95. So that's mean none of them. Okay. The last question is this one. Okay, so here this is also sampling distribution of proportion. So the previous one was sampling distribution of mean, and this is the sampling distribution for proportion. So here P is 0.3. Assume that the precedent is correct and probability is 0.3. So what is the sampling distribution of P bar? So that's mean the average for this study. So that's mean the sampling distribution for this proportion. Okay. So in case of proportion, the sampling distribution is, so the sampling distribution will be P bar or P tilde. This is actually normal distribution with mean mu and standard deviation, this mu P. Okay, so in this case, we do not know the mean mu, right? in this case, the mu p bar will be actually p times 1 minus p. Oh, I'm sorry. So this one will be actually n times p. The sample size times the proportion of success, n times p. And sigma will be, sigma p bar is equals to square root of n times p times 1 minus p. I'm sorry. Yeah, 1 times 1 minus p. Okay, the variance is n times p times 1 minus p, and the square root of the variance is standard deviation, which is sigma p bar. Okay. So similarly, assume that the what is the sampling distribution for p bar? So okay, so to determine whether the sampling distribution for the proportion will be normal or not, you have to calculate these two numbers, n times p and n times 1 minus p. So n times p here is 30, 0.3 times 100 is 30, and 1 minus p is 1 minus 0.3, which is 0.7 times 100 is 70. So both of them are greater than 5. This is also greater than 5, this is also greater than 5. If these two numbers, if both of these numbers are greater than 5, then the sampling distribution will follow normal distribution with mean n times p, and the standard deviation is this one. So you can say this is normal distribution. What is the probability that the sample proportion will be between 0.2 and 0.4? So that's mean you have to find the probability of 0.2 and p bar 0.4. So you have to find this probability, and you know the distribution of p bar. This is the normal distribution with mean n times p. So that's mean n times p is 30. So this is 30, and n times p times 1 minus p. So n times p times 1 minus p, which will be actually 100 times 0.3 times 0.7. So this one will be actually 21, I think. Yeah. So the standard deviation will be a square root of 21. So standard deviation is a square root of 21. Here the standard deviation is this one, and this is the mean. So you know the mean, you know the standard deviation, and you have to find the probability between these two numbers. So you can just use the Excel. You already know how to do it. Similarly, what is the probability that the sample proportion will be between this one and this one? Is the same, similar problem, same problem with different numbers. So you have to just use this mean and this standard deviation, and you have to find the probability between 0.25 and 0.35. Okay, so I hope you will be able to do that, and also try all the multiple choice questions. So if you have any problem with to understand any questions, you can just email me. I'll try my best to answer your question. Okay, and your exam will be basically mainly your exam is on Thursday. So what I can do, I can open your exam on either on Thursday, since on the syllabus it should be opened on Wednesday, but I wanted to open on Thursday. So what I can do, okay, I'll email you more details about the exam. Okay, so good luck on your exam. Thank you.